Hey guys, this is the Physics 2212 Lab 4 series parallel and RC circuits. Sorry, I kind of lost my voice, so just bear with me. The purpose of this lab is to observe and use a loop rule and node rule using a virtual simulation in the program Circuit Construction Kit. Other purposes of this lab include familiarizing ourselves with the use of ammeters and voltmeters and calculating the time constant of an RC circuit, which I found to be 5.988 seconds, and comparing the calculated value with the value in the virtual lab. The important concepts used in this lab, the loop rule and the node rule, are also known as Kirchhoff's second law, the law of energy conservation, and the law of current conservation. In the first part of the experiment, I set up a series circuit as seen in the two pictures, and using Kirchhoff's second law, predicted that the current in the loop would be 0.0204 amps. This matches the value measured by the ammeter in the simulator, which is 0.02 amps. Because the resistors are in series, I was able to sum the two resistances together to get an equivalent resistance, and using this, I was able to calculate the current. Next, I put a voltmeter in series with the circuit, and its measured value was 3 volts, which is equal to the equivalent or total voltage in the loop. The ammeter measured a current of 0 amps because the voltmeter has a very high resistance, which prevents nearly any current from flowing through it. Next, I measured the potential difference across different places within the circuit, and when summed up, I found that the change in voltage for the entire loop was 0, which follows the loop rule. Then I graphed those values across the different points in the loop, and the steepest slope was found to be across the 100 ohm resistor, which shows that the electric field across that point is the largest. This also follows what we know to be true about circuits, because the resistance here is the highest, but the current in the whole circuit remains constant. Parallel circuit question. In this part, I observed what happened when I added things in parallel to my circuit. Question 1. Attaching the voltmeter alters the circuit. Why doesn't the ammeter reading change? The voltmeter is connected in parallel to the ammeter, and resistance in the voltmeter is very high, so therefore no current will flow through the voltmeter because there is a path of low resistance available. Question 2. What happens when you place an ammeter in parallel with the 100 ohm resistor? The reading on the ammeter goes from 0.02 amps to 0.06 amps. This is because the current now ignores the path with the 100 ohm resistor, and all of the current now flows through the ammeter. In the RC circuit, I looked at what happens when the bulb was connected to a battery and a capacitor. The bulb started shining brightly, but then began to dim as the capacitor charged until the current eventually approached 0. The same behavior can be observed when I remove the battery and the capacitor slowly begins to lose its charge, and the current again returns to 0. For a 10 ohm bulb, I found that it took about 8 seconds for the capacitor to charge and 10 seconds for the capacitor to discharge. When I increased the resistance in the bulb to 20 ohms, I found that the time for both of these essentially doubled, indicating a directly proportional relationship between the time it takes to charge a capacitor and resistance. The charging and discharging of capacitors are exponential, and so in this slide we had to graph the natural log of the potential differences over time to calculate the time constant RC. By taking the slope and setting it equal to -1 over RC, I was able to get 5.988 seconds as the time constant. This is very close to the simulated value of 6, which was found by multiplying the resistance of the bulb times the capacitor's value of 200 millifarads. Real life versus virtual simulations. The biggest difference between experiments in real life and virtual simulations is that in virtual simulations there's such thing as no resistance. However, we do not live in a perfect world, so every material that we experiment with will have some kind of resistance. Therefore, you would see an increase in overall resistance, a decrease in current, and an increase in the time to charge a capacitor in the real world. In conclusion, I was able to virtually observe circuits and utilize the loop rule and node rule to calculate current, resistance, and time constants. I also found the time constant for my RC circuit to be 5.988 seconds. Thank you for watching and listening, and have a good day.